Hello fellow problem solvers, so today we're going to be doing a problem from the Tournament of Towns, Senior A Level, Fall of 2003, problem number 4. This is a lovely geometry problem, quite cute, quite nice, that I invite you to try out for a minimum of half an hour, ideally an hour, but not more than 2 hours. If on the other hand you'd like to go along with us, I suggest you draw a diagram and put your first ideas out on paper for the next 10 to 15 minutes. And I should just mention that the end circle refers to the circumcircle here. So now, without further ado, let's begin. So, when you first draw the problem, this is sort of the diagram that you have. You have IO parallel to BC, and you must prove that HK is parallel to AO. Now, the first thing that you may want to do is ask yourself, how do I use the condition that IO is parallel to BC? And I invite you to pause for 5 minutes and figure out how would you use this condition. And the answer is there are many ways, but depending on what you know, you will use different things. One way to use parallel conditions in general, not just for IO, is to know that that means that the distance from I and O to BC is the same. And you can calculate it like the distance from I to BC is equal to R, and from O to BC, so if you draw this perpendicular, then this is the midpoint M, and then you have, this is alpha, because both this BOC is 2 alpha, so then you have, this is cosine of alpha times OC, which is R, so you have little r is equal to cosine of alpha times the big R. And now you may want to also try to solve the problem backwards to ask yourself, how do you prove HK is parallel to AO? I invite you to take 3 to 5 minutes and figure that out. And again, depending on what you know, there's different things that you may try. One thing is that you know that the angle OAH, that this angle, because this is 90 minus beta and this is 90 minus beta, that means this is beta minus gamma, assuming AC is bigger than AB. And what you also have is that if HK was parallel to AO, that means that the angle KH, and let's call this perpendicular D, HKD would be beta minus gamma. Oh, actually I meant to say KHD. But anyway, we would need to prove that KHD is equal to beta minus gamma, that this follows this is equal to beta minus gamma. And one way to prove this is that the tangent of the angle KHD, which would have somewhat nicely, we need to prove that this is equal to the tangent of beta minus gamma. Because if tangent of x is equal to tangent of y, then it follows that either x minus y is 0, or that it is pi or 180, depending on how you want to look at it. But then this would imply, because this angle is obviously less than 90, this would imply that this is beta minus gamma. And that's one way we could do it. And we know that the tangent of beta minus gamma is equal to the tangent of beta minus the tangent of gamma over 1 minus tangent of beta tangent of gamma. And we can maybe calculate this, figure out if this thing right here, so the tangent would be dk over hd, we can figure out if that ends up actually equaling this when we get all the sides out. Actually, this is here a plus, so we would need to prove this. And the way we would do this is we can also just like, this is beta, this is gamma, and then we know that tangent of beta is equal to what? It's AD over BD, and tangent of gamma is equal to AD over CD, and then this thing right here would transform into DC minus BD over DH plus AD, and we will need to prove that this thing is equal to this thing right here. And now, depending on your trigonometric abilities, you may want to try to prove this and finish the problem. If you do want to go down this route, I suggest a minimum of 15 minutes, ideally 30, but not more than an hour, working on proving this. But I will make my solution with trigonometry as the official sort of solution. But now let's try to look and explore and look for some nice things. Look for synthetic solutions. So here the thing that really strikes your eye depends on what you know. And for me, when I first saw this, like this is how I thought of using this problem condition, but I then looked at what I also know to be true. And that is, say if n is the midpoint of AC, then we have ON, CM, these 4 points are concyclic, and this angle, O and M, is equal to O and C, which is 90 minus alpha. Similarly, this right here, OMN, is 90 minus beta. But where do we also have 90 minus alpha and 90 minus beta? Well, we have it in the triangle AHB. Now, this gives us a similarity. It tells us that ONM and HAB are similar. And given that AB over MN is equal to 1, is equal to 2 over 1 is equal to 2, that means that AH is twice the size of OM and HB is twice the size of ON. So that makes me look at this whole problem and think to myself, wait, I have AH is equal to 2 times OM and is also 2 times IK. Maybe there's a way for me to use this. And I also know the fact that the midpoint of AH, if that midpoint is say S, what I also know that is that SMD lie on the Euler circle of ABC. And that might be interesting as well. So these are some of the facts that I know that I am using in trying to solve this problem. And now with these facts, I invite you to pause for 5 minutes and figure out if you can figure something else out, if you can push these facts further. Here's the next idea. So here is what this OM is equal to IK gives us. It gives us AOMS, SOMH, AIKS, SIKH. It gives us that all of these are parallelograms. And what do these parallelograms give us? Well, they give us AO parallel MS, SOMH, AI parallel to KS, SI parallel to HK. And now what you see is that, well, we have HK is parallel to SI and AO parallel to SM. So the only thing we need to prove is that SI and M are collinear. And now how difficult is this to prove? And now here are a couple of ideas that come to mind. One is, well, we know that, so SI is parallel to HK, maybe SI is parallel to this. We have SM is parallel to this. Maybe prove that SI is parallel to AO, or that IM or SI parallel to AO. Maybe try to prove this. Is this plausible? Well, maybe how do we prove this is parallel to this? We know IO is KM. Maybe this one. We would still need to prove this angle. We can do trigonometry. Okay, again, trigonometry. So let's draw. So what do we have? We have points A, S, H. Then we have I, K, O, M. And we have this is perpendicular to this. Perpendicular, equal. And now, yes, we have S, I, M need to be collinear. Is this always the true? If I move this here, it doesn't seem like it would be true. I prime, O prime, K, M. Nope, not true, because this stays fixed, this moves, so this line moves. So now this sort of tells me that we need to use something that's specific to these points, KIM. We can't just use this. Maybe with the fact that these two angles are identical, that IAH and IAO are the same. Could we maybe use that in trying to prove that this is parallel to this? Maybe what we would need to prove maybe is, if I'm not mistaken, that SI, if this is parallel to this angle is equal to this one, which is this one. So maybe AS is SI, and then maybe HIA is 90. Maybe that is all we need to prove. Now that could be interesting. Maybe HIA is 90. I mean, actually, it seems like it has to be 90. So if this is then 90, then we would have, so SI is, so we'd have SI is SA is SH, is this. Okay, then because SIKH is already parallelogram, it will be a rhombus, so SK would be perpendicular to HI, so maybe that is what we need to prove. Or maybe we can be looking at other things like this is 90 if and only if, so this is beta minus gamma half, so if and only if this was 90, then cosine of beta minus gamma half will be equal to AI over AH. So maybe that's a thing to prove. Maybe we can look at what does it mean more in general. What does it mean for AI? This would mean that I is on the circumcircle with diameter AH. And maybe that's something interesting. Okay, and maybe there's something we can do with this given our initial condition, but let's look at more. So ASIO, okay, maybe let's look at what if IM is parallel to AO. Well, then what do we have? Well, maybe if we extend this, then this thing right here would be a parallelogram. So then this would be equal to that. Oh, wait a second. So if this is I, if this is, say, R, I don't think I've used, yes. If this is R, then RI is OM, is AS. But this is R. So this thing would be on the incircle. So the incircle would intersect this here, which we get from many sides. You also get it here. This would be equal to this, equal to this. Okay, so maybe that's the thing we could be looking at. And how do we go about proving that? Well, we would need to say we intersect it here. Then we would need to prove that this is parallel to this. And that's true if this over this is this over this. Can we prove that? And now with these maybe a couple of ideas, I invite you to pause for 5 to 10 minutes and figure out which one you're going to choose and which one you're going to work on. And at this point, the idea I would choose to work on, just because I know a lemma, would be the final one. Namely, the reason I would choose that one is actually just using another somewhat known lemma. If you're doing geometry a lot, if you're like an intermediate geometry problem solver, then it's a fairly known lemma to you. It is that if you have a triangle ABC and say the incircle touches BC at K and the X circle opposite side A touches it at point T. Then if you take KI intersection, the intercircle, call that point R, then ART are collinear. And the way you prove this is via homothety from this that has a center of A and takes the incircle to the X circle. And the reason this works, like you can also look at it, like you draw a parallel through R, then it's tangent to the incircle, and now you have this smaller triangle called B1C1, where B1C1 are collinear and B1C1 is parallel to BC. And now you would have that these two triangles are similar, and they're similar in the same way. So now, because this is the incircle of ABC is the X circle of B1C1, so these points are collinear. Like they form the same angle, like RAC1 is same as TAC because of similarity, and then you have ART are collinear. And now if we bring that lemma up to our original problem, what we have is our triangle. So now what you have is this ART, because this is where the X circle touches BC. That means that BK and TC are identical, are the same length. Call this M. That means KM and MT are the same length. And now we have this RT is the same as OM. Like RI is IK is OM. And now what do you have? You have two perpendiculars, you have a midpoint. You have this is like RK is half of OM, which means that ROT are collinear. And because ART are collinear, that means that R is an element of AO. And now this solves our problem actually quite quickly, because now you have that this is the I is the midpoint of RK, M is the midpoint of KT. So IM is parallel to RT, which is identical to AO, but we know that IM, due to the point S here, actually, yeah, IM is parallel to this. And now, wait, how do we finish this up again? Oh yes, and we know that this is also parallel to SM, that AO is parallel to SM. And what we also know, so now this gives us that IMS are collinear. And given that they are collinear, what do we have? We have SIM are collinear. And now this gives us HK. HK is parallel to SI, and SI is parallel to SM, is parallel to AO, which implies HK is parallel to AO. And here I invite you to take 10 minutes and try to write a page solution, maybe up to 30 minutes. And here's my trigonometric solution now. Bam! This is the trigonometry setup. Now, before we go into this, I just want to point out that this actually took a lot of trial and error as to figuring out what should be done and what shouldn't be done. And the first thing in the setup is what the condition implies. And the second thing in the setup is what we are going to prove, that HK is parallel to AO. And we know that this is true if and only if dk over HD is the same as dc minus bd over dh plus ad. And now we do the calculations. That is the second step. And the calculations are done like we have this. And now we can actually manipulate this, that what we need to prove, namely dk over dh is equal to what? Is equal to dc minus bd over dh plus ad. And we have this is true if and only if. And we get this, that all of this is true if and only if dh times a plus b plus c is equal to ad times b plus c minus a. And now, because ah is 2 cosine alpha times r is equal to 2 times the little r, and this is true because both of these are equal to the area of the triangle ABC. So, because this is true, that implies that HK is parallel to AO. So that means that OI parallel to BC implies HK parallel to AO. And now we're done. And as always, thanks for problem solving.